Good evening, everyone. Thank you for joining us. Just give everyone a minute or two to make sure everyone gets into the platform here. My name is Lauren Zarillo. I am a regulatory officer here at DEP, and I'm just going to go over a few preliminary things so we can get kicked off, and I will kick it over to Assistant Commissioner Vince Mazzei to give us our presentation this evening. So first of all, you may have noticed that we are recording this presentation. It will be posted on our website. And as many of you know, there was a presentation yesterday that is already on our website, and the PowerPoint slides that we're going to be going through this evening are on the website as well. I know those are very common questions, certainly, so they are on the website and you can access them. Everybody here is going to be muted and have their cameras off this evening. This is a new platform for us, so please try and bear with us. We're trying to do the best we can to get as much input and stakeholder engagement here as we go along, but we do have some technical issues. We do have some IT staff on. If you have an issue, hopefully they can help you out there. We're going to keep questions turned off for the time being, and it's not that you won't have a chance to ask them. You certainly will. It's just that we'll just give Assistant Commissioner Mazzei the chance to go through his presentation, because I think he'll answer a lot of the questions as they come up. So towards the end of the presentation, we're going to have the questions turned on. So here we don't use chat function, we use the question function. And if you put your questions in there, we will try and get to as many of them as we can. We are here until 8 o'clock, so we will try and get through as many as we can. And if we don't get to your question, there's definitely plenty of other ways that we want to hear from you, including through the normal administrative procedures process and our comment period, and certainly sending us emails and other ways. We are happy to hear from you, and we're so thankful you're joining us here this evening. And with that, I will give it over to Assistant Commissioner Mazzei.
Thanks, Lauren. And I'll take another minute just to make sure that everybody can get on, because I can see that the number of attendees is increasing as we go. But first, let me just say thank you for taking time on a Thursday night for this. Obviously, we all believe that this is very important, the protection of our people, and making sure that standards are commensurate with the risk associated with flooding and stormwater is worth the time. So I just want to put out there a heartfelt thank you for joining us on a Thursday evening. And I still see the number of people going up, so I'm just going to give it another 1 minute and then we'll start. In the meantime, I want to also say that this is kind of a follow-up to what we started a while ago. A number of folks may remember that we had a series of stakeholder meetings and engagements a couple years ago where we first started to talk about NJ-PACT and the different things that were related to it that we were proposing. And then in May, well, I'll backtrack a little bit. In May, we talked about having an emergency rule. Now, what I'm going to do tonight is kind of walk you through how we got to where we are, what we propose to do, why we propose to do it, and why we think this is important for the state of New Jersey, and kind of give you the basis and background for a lot of it. But like all good stories, right, you don't want a spoiler, but I'm going to give you a spoiler first. The spoiler is that we don't anticipate filing an emergency rulemaking like we announced in May. What we're planning to do is take the material that I'm going to show you tonight and propose it as a regular rulemaking, which has a 60-day comment period, and we'll have ample opportunity for everyone to review and comment. And then the department reviews all those comments, responds to those comments, and then the rule becomes effective at the end of the process, unlike an emergency rule that would be effective immediately. So that's the main change. Is for anyone that was here in May when we talked about the emergency rulemaking, it's the substance of this rule is almost exactly the same. It's just that the process is a little different. So with that, let me start. All right, hopefully everyone can see my slides advancing.
Yes, we can.
All right, thank you. So a little background first to kind of set the tone of why we're doing what we're doing. Flooding in New Jersey is a chronic problem. It's something that has plagued us for centuries, really. And in fact, New Jersey ranks as third highest state in the nation for NFIP claims. And I believe we rank second in the nation for NFIP violations. So we have significant flooding problems and problems with compliance. Now, how much of the state lies in the floodplain? We have FEMA flood maps that cover the larger streams and rivers and the coastlines of the state, but don't cover all the small tributaries. Now, if you look at the FEMA floodplain layer, it's over 15% of the state lies within a map floodplain. And of course, that includes a lot of our population centers because a lot of our population centers are along water. The next thing that is important to understand, to kind of set the background to this, is that the publicly available flood mapping, the FEMA mapping, and the state mapping is not complete. It doesn't include all the streams, and unfortunately, often underestimates the actual flood risk that you might have. And so it's very difficult for people who are buying, occupying properties, renting, planning to build, to know the actual flood risk on a site based on the mapping that we currently have. And we could talk a lot about all the different related issues to climate change that infect things like sea level rise. But today we're going to focus on riverine or fluvial flooding. Now, New Jersey, because we're along the coastline, we have two kinds of floods, right? We've got riverine fluvial flooding, and we've got coastal flooding. They have totally different causes, different flood dynamics, and there's different safety concerns as a result. So I'm going to touch a little bit on both, but mostly we're going to focus on the riverine flooding today. Now, New Jersey is blessed with a lot of waterways, and that's one reason why it was settled by the colonizers and by Europe. And pretty much every town, if you think about it, has a waterway going through the middle of it. There's a mill, or there's some kind of transportation network that was established years ago, because that's what waters were. They were the roadways of the past. And so most of our population centers have some portion of it in a flood hazard area today. And on top of that, older development, buildings that were 100 years ago, 50 years ago, more, roads often weren't built with regard for the potential flood risk because they just didn't know, right? They could look at historic data, maybe a high water mark if someone knew that in a town, but a lot of development just happened based on what was understood at that time, and the risk was not known. And so we even see that today, that when people don't know the risk, they can't make good choices as to where they live, where they work. Now, to compound that, the flood mapping that we do have is based on what has happened in the past. And it's using data that's been collected over the last few decades, right? So flood data from gauges around the state, or other means of collection of data were used to put together these flood maps based on the rainfall that we've had in the past. But things are changing because of climate change. And so it's our belief that, and we'll talk about this today, that the flood mapping that we have doesn't accurately reflect the flood risk in a lot of communities. And it certainly doesn't include any kind of climate change factors that would be a predictor of flood risk in the future. So the mapping was never really a truly accurate predictor of flood risk. It's a good starting point, but it's no longer, in our opinion, a sound methodology for estimating actual flood risk due to climate change. So let me talk a little bit about the terminology. What is a 100-year flood? What is a 500-year flood? So a 100-year flood, it's more accurately described as a 1% flood. I've shared this story before. Years ago, I was working with someone who wanted to build a home along the Delaware River, and I told them how high they needed to set the floor of their building based on the flood, the 100-year flood. And they said, well, when was the last time we had a flood here? And I said, well, 1955 was the flood of record in the recent past. So the person thought about it for a moment and said, well, the next flood's going to come in 2055, and I'll be dead by then, so there's no point in me worrying about what floor elevation I have. And there were really 2 points that I made to him. I said, one is, well, the decisions that you're making today are going to affect whoever's going to live in this house in the future. And second, we don't know that the flood's going to happen exactly 100 years from now. And that's the problem with the terminology. It's not like we know that today is the day that the flood's going to come, because it's exactly 100 years after the last flood. So it's more accurately described as a flood that has a 1% probability of occurring in a given year. And On average, over a very long period of time, yes, this flood has a chance in aggregate of happening once every century, but we'll call it a 100-year flood is really 1% flood. So similarly, a 500-year flood is more accurately described as a flood that has a 0.2% probability of occurring in any given year. So again, on average, this flood will occur about once every 500 years. At least that's what our expectation would be based on the data that we've collected. But we see now that that's not the case, and I have some examples of that. Now, there's nothing particularly special about a 100-year flood or a 500-year flood. These are probabilities, and the 100-year flood became common years ago as a means of determining the worst flooding that a structure might endure during its lifetime. And so mapping is a good starting point, but what we saw, for example, during Ida and in many storms that we've seen is that the flooding that actually occurs sometimes greatly exceeds the mapped floodplain limits. The flood doesn't know it's supposed to stop at that line on the map. And so as climate change progresses and precipitation events become more intense, and there's more water being transported through floodplains than before, you see erosion, you see structures collapsing, you see floodplains getting bigger. And we've seen that over the last few decades. Now, why this is so important is that people should be aware. We want people to be aware, all of us do, of the flood risks that they might face when they're buying, when they're renting, when they're occupying or developing property. But it's often very difficult to determine the true risk because the mapping isn't complete and it doesn't reflect even today's conditions, much less future conditions. Now, just a note on the difference between fluvial and tidal flooding. Now, I mentioned that we're going to focus mostly on fluvial or riverine flooding today. Riverine flooding is caused by stormwater runoff from extreme precipitation events. So it's the floodwaters are trying to move through the watershed from the upper reaches of the watershed down eventually to the ocean. So eventually all the water gets to the ocean. And the thing that's important about riverine flooding in particular is that it can happen very quickly. You can have flash flooding, and that can cause significant damage and loss of life. Tidal flooding is a different dynamic. It's caused by tidal surge during a coastal storm. And of course, there's significant damage, but that damage is generally caused by the wave action. And of course, the hydrostatic pressure of just the water coming up. And it doesn't generally happen quickly, right? We know when a hurricane is coming. We know that there's a likelihood that a hurricane is coming. Most of the communities along the coast have evacuation plans. People have some time to prepare. And that is very much unlike fluvial or riverine flooding because it can happen in a split second. During Ida, a neighbor of mine, within about 15 minutes, the creek that is near his house went from being in the bank to on his property and then up to the second floor window of his house within about a half an hour. And he showed me the video because I could hardly believe that it could happen that fast. So just to kind of summarize, most state and federal flood maps are based on hydrology from the past because that's what we have. We had rainfall data from the past decades. The mapping is incomplete. It doesn't show all the floodplains in the state. I did a kind of a tour of all the streams around my house because I wanted to see what their drainage area was and what kind of floodplains mapping there was. And there's only one stream or river or creek in my vicinity that has a flood map, and that has a 24 square mile drainage area. There's a stream not too far from me that has a 1 square mile drainage area. 1 square mile is 640 acres. So that drains a lot of land, and it doesn't have flood mapping because the flood insurance rate maps can't cover everything. So it's our understanding and belief that the mapping generally underestimates today's flood potential and doesn't, of course, account for increasing precipitation that's happened in the last couple decades or due to climate change in the future. Now, what are these effects of increasing extreme precipitation? And we saw this during Ida, added stress on already overtaxed infrastructure, stormwater management systems that were not likely even designed to carry today's 100-year storm or the past 100-year storm, are being asked to carry a lot more water. Streams that were designed or formed over thousands of years carrying a certain amount of water are now carrying more water because more runoff is getting to them more quickly. And so that's why we see a lot of streams eroding. We see incising of the channel where the channel erodes down and then the banks fall in, and then the channel gets bigger, and that's a dynamic that seems to be happening all over the state. Increased precipitation overwhelms stormwater management systems, so time and money and energy was put into putting stormwater management systems in place, and we saw a lot of them being overwhelmed by the increased precipitation. Of course, there's increased fluvial flood depths as a result of all this water, and that results in an increased risk to life and to property. Now, why is this happening? As climate change progresses and the temperature of the atmosphere is getting warmer, there's more energy in the storms, and it allows the atmosphere to hold more water, and that increases the potential for more intense precipitation and flooding events. By the end of the century, heavy storms are projected to occur between 200% and 500% more often and with more intensity than in the 20th century. And I don't have to remind everyone here because I'm sure everyone here has experienced at least one of these floods. But just since 2000, here's some of the major floods that have hit the state. And when I do talks in public, usually in the beginning, I'll ask for a show of hands and say, how many people here were directly impacted by flooding in the past couple decades, or have a friend or a family member that was directly impacted? And almost every single person raises their hand. So this is something that we're all in together, and it's incumbent on the government to step in and do what we believe is right, and it's also for the best interest of the public safety and the ability for people to make good decisions. So some of what we're going to talk about tonight, a lot of it is based on a study that DEP worked with the Northeast Regional Climate Center, which is a partner with NOAA. And there was a study that was released in November 2021, almost a year ago, that does two things. One, it confirms increases in extreme precipitation that have occurred in New Jersey over the last 20 years, and I'll unpack what that means. So in the past 20 years, we've seen extreme precipitation increase, and it projects further increases in precipitation intensity over coming decades. So what's the proper response to this? Well, the data that's presently used to analyze flood potential in waterways only includes data through 1999. So when you're designing a stormwater management system today, or if you're trying to calculate the limits of a floodplain, you're using rainfall data from NOAA, but that only includes data through 1999. It doesn't account for any increases in precipitation that have happened since then. And so all of these expectations that presently guide state policy and planning and development rely on this data, so they don't accurately reflect the current risk. They don't reflect the current precipitation intensity. Now, simply stated, if we get more rain, we're going to get more runoff. If we get more intense rainfalls, we're going to get more intense runoff. More intense runoff means increased riverine flow, and more flow in the rivers means a higher flood elevation, and that means more flood damage. That means more people in the floodplain. That means people who are outside the map and who don't have flood insurance might be at risk and they don't know it. And we're seeing that more and more. During Ida, a large percentage of the flood insurance claims were for folks that were located outside the special flood hazard area. Now that's significant because only people who have a mortgage and who live in the floodplain are required to have flood insurance by their lender, right? The lender wants to ensure that the property is protected, and so they require that you get flood insurance. A lot of times when people pay off their house and they're older people on fixed incomes, they drop their flood insurance and then they're at risk. And the people outside the flood line aren't required in the first place. But a large number of folks during Ida were located outside the floodplain who had flood insurance claims. And so that tells you that the flood is increasing in a lot of cases. Now, the way this plays out, based on what I said before, we have our current precipitation and our future precipitation. Now, current precipitation really isn't current. It's really 1999. And studies have shown that, the study that we speak of shows that the 2-year storm has increased by as much as 5%, the 10-year storm has increased as much as 7%, and the 100-year storm has increased as much as 15% in different parts of the state. And I'm going to show you a table that shows the different amounts per county. So that's what's happened already, just since 1999. Then the second piece is what's going to happen in the future. So by the year 2100, by the end of the decade, 78 years away from now, the 2-year storm is likely to increase by as much as 24%. The 10-year storm is likely to increase as much as 27%, and the 100-year storm in some counties, as you can see in that map there, like in the dark blue areas, as much as 50%. So that's the intensity. So a rainfall that 100-year storm in Sussex County, maybe it's 9 inches today, it's going to be 50% more than that by the end of the century based on these estimates. Now, when we say that there's a likelihood of this, there's a range of projections, and we take the data and we look at the various percentages of increments that would be exceeded. So for example, if we say there's a 50% likelihood that something's going to happen, that means there's a 50% likelihood that it'll be more or less, right? So the likely range is generally between 17% and 83%. So in other words, there's a value where the rainfall, there's an 83% chance that or probability that the rainfall will exceed, up to a 17% chance. So we've taken that likely range and we've used the 17% value, which means that there's only 17% chance or likelihood that, based on our data, that storms will increase more than the amounts that are shown here. And here's what it looks like for each of the counties. On the left, you can see an adjustment from the 1999 rainfall to 2019, because that's inclusive of the data that was used for the 2021 study. And you can see in some cases it even goes down a little bit, like in Burlington County, but it's minimal increases in most cases for the 2-year storm, a little more for the 10, a little more for the 100-year. Warren County saw the most, 15% increase, Hunterdon County 13% for the 100-year. That's just in the last 20 years. And then projecting forward based on the data, we can see based on where you are in the state, the 2, 10, and 100-year storm, and how they will change as a result of increasing climate change. Now, we saw, tragically, what this looks like during Ida. Now, I want to underscore that this rulemaking is not just based on what we saw during Ida. What we saw during Ida is, unfortunately, an example of what we're going to see more and more because of climate change and what we've seen. And so I'm just going to kind of walk through what happened during Ida and what it looked like, and compare the flooding from Ida to our flood maps and show you the vulnerability that some folks had in certain communities. So anyone who's experienced it, there were record rainfalls, 10+ inches of rain in a large swath of the state. Newark experienced its all-time record high for a 1-hour rainfall. I live in Hunterdon County. I looked at the gauge nearest me in Kingwood, and it was pretty much off the charts for rainfall intensity. Literally, it wasn't even on the chart. So what happened is that all this runoff was occurring very, very quickly. So storm sewers were very quickly overwhelmed. Streams and rivers couldn't convey so much water in a short amount of time, and more than 12 rivers in that region exceeded their 100-year flood levels. And tragically, it directly resulted in the loss of 30 lives. And that is largely because people were trapped and could not get out of their buildings or their cars, their vehicles. There were a lot of deaths in vehicles. And it's different than Sandy, because Sandy had a higher number of deaths in the state, but it was due to certain different factors. But as far as flooding goes, 30 lives were directly lost from a bad thunderstorm. I want to underscore that too. This was the remnants of a tropical storm. It wasn't even a hurricane when it hit. It wasn't even a tropical storm when it hit New Jersey. And you can see from this picture here, and I don't know if you can see my cursor, hopefully you can. This is a picture taken from the parking lot of the ShopRite in Flemington. And you can see that there's no stream anywhere near this. And yet Route 202 had about 3 feet of water in it, and Route 202 became a river. How did this happen? When I first saw this photo, I thought there must be a stream nearby that I don't know about. And of course there isn't. It was all runoff from all the historic development in the center of Flemington and Raritan Township that couldn't get to streams fast enough through the storm sewer systems, and it overwhelmed the systems and it went down the highway. And we had deaths on Route 202 as a result because people were trapped in their cars within minutes in some cases. So what we did, and I'm going to show you these examples, is we looked at different places around the state that were impacted by Ida and compared them to the flood mapping that we have for that same area. Now, many of you who are familiar with the flood hazard rules know that the term that we use, the design flood elevation, that is our regulatory flood elevation. That's the flood elevation that we regulate to and require people to build to. And that's determined today by either using the flood elevation that's mapped by the state. There are a number of rivers in the state that have mapping by DEP, mostly done in the 1980s, that show where flooding was at that time. And of course, FEMA has their flood mapping, and they periodically improve their mapping and include better topography data. In some cases, include better hydrology. But we regulate a flood that's bigger than FEMA's 100-year flood. So when we say the special flood hazard area, we're talking about FEMA's 1% flood, the 100-year flood. We regulate a flood that's at least a foot higher than that. So today, you use the higher of whatever's shown on the state map or the 100-year flood plus the foot. And if you have to calculate it, then you have to calculate the flow rate and add a 25% factor of safety and model that and show this is where the floodplain is. So and this goes back as far as the 1970s. We recognized that floodplains were getting bigger, likely due to development. Now, when we compared the flood mapping that we have for the areas that were impacted in Ida and the actual images that we have from Ida, on average, the flood elevation was a little over 3 feet above FEMA's 100-year flood elevation, which is 2 feet higher than today. So let me show you a few examples of this. Now, I recognize that a 100-year storm doesn't always cause a 100-year flood event. There's a lot of different dynamics that happen there. And that in some cases, the rainfall intensity might have been, again, like nearby my house was off the charts. But what we saw happen was an increase in the frequency that the flooding was being exceeded. So for example, the Raritan River along Bound Brook, there's a gauge there, USGS gauge. And you can see on the left, there's a little box and it shows Ida. Ida matched what happened during Hurricane Floyd. Hurricane Floyd was a much larger storm, covered a lot more area than Ida did. And it was the same flood elevation, which at the time was the worst ever recorded in Bound Brook. Ida peaked about 3 feet above FEMA's 100-year and actually above FEMA's 500-year flood elevation at the location. Now, this is the point that is startling to me. The 500-year flood at this location has been exceeded 3 times since 1999. Right? We had Irene, we had Floyd, we had Ida. If you're having 3 500-year floods in a 22-year period, to me that illustrates that there's a problem with the statistics, because again, it's based on past events, and stationality is dead. We know that things are increasing. We know that precipitation amounts are increasing. We've seen it already, and this is the unfortunate result. Here's another location, the Neshannock River at Reeville. I don't have a flood map for this point, but flooding during Tropical Storm Ida was over 4 feet above Hurricane Floyd, which had previously been the highest elevation ever recorded at this location. So that's significant. The next couple slides, I think, illustrates the very basis for everything that we're doing here. Here is a section of Manville on the Millstone River before Ida. And here is the same location during Ida. And you can see all the areas that are inundated by floodwaters. And I want to, just as a side note, point out that floodwaters have an incredible amount of pollutants in them. Because if you think about what you have in your garage, or the cars, or the different industries and whatnot that are flooded, and all that is coming into the water, and it's being spread over the whole neighborhoods, it causes problems in and of itself, aside from the flooding. But if we just focus on the flooding, you can see the extent of flooding. And I'm going to show you an overlay as close as I could get to the FEMA flood map. Okay, so you can see here's this L-shaped building here. And you can see the gold or the orange here is the limit of the 500-year flood, the 0.2% flood mapped by FEMA. And this 100-year flood limit, the 1% flood, is the blue. And this tells you the elevation. You can see this whole area, this whole neighborhood is not shown as a mapped floodplain. Let me toggle back. All of these people were flooded. These people were not required to have flood insurance. We don't know how many did or didn't. We don't know how many of these people had basements. We don't know how many people of these houses were destroyed, but none of them were required to have flood insurance. And so we're all paying for the cost of that when there's a relief for flooding, if there's money that's available, or if there's disaster relief funds that are available. Ultimately, that's coming from all of us. One of the statistics that I saw that I thought was shocking was after Hurricane Sandy, there was a graph that showed the amount of people that were applying for unemployment insurance for the first time each week. And it was pretty static throughout all 2012. And then when Hurricane Sandy hit, it tripled because so many people had no car, they had no business, they had no home, so they couldn't work. So they all applied for unemployment insurance, and we all pay for that. So the society is carrying the cost of the decisions that people are making when they build. And that's what we're trying to make sure, is that people are informed so that when they build, when they buy, when they occupy, that they know the risk that they have and that they can prepare for that risk. Here's another illustration, again, along the Millstone River at Manville before Ida. This is during Ida, and you can kind of see how the water came up these streets to these locations here. Hopefully you can see my cursor here. And I'm going to show the flood map for that same area. It exceeded, matched pretty well, but in some cases exceeded the 500-year flood limit in these areas as well, right? So all these people out here are not required to get flood insurance, yet they were all flooded. So flooding peaked at roughly a foot between the 500-year and about a foot above, depending where you were, which is about as much as 2.5 feet above the 100-year flood elevation. So flooding in Manville was about 3.5 feet above FEMA's 100-year flood elevation. And one last image. Here's Bridgewater, the Raritan River, at the stadium. You can see this is before Ida, this is during Ida, and if you look at this little triangle here of parking lot that is out, it matches up almost perfectly with the flood map. So pretty much track the 500-year flood almost exactly. And the 500-year flood is 2.8 feet above FEMA's 100-year, right? So when you put it all together, I'll go back a slide. When you put it together, as I mentioned earlier, the flooding that we saw was about 3 feet higher on average than the 100-year flood. And today we regulate 1 foot higher. So added cost is being put into building homes higher and building businesses higher and roads and infrastructure higher. And it wasn't enough. It wasn't enough to protect them against Ida. So what's the scope of this rulemaking that we're proposing? So it addresses 3 issues related to increased precipitation due to climate change. The first is that the current rainfall data that we use in our rules isn't really current. It was only computed through 1999, and we now know that that's increased since then. The second thing is that our stormwater management and flood hazard rules don't account for future increases in precipitation due to climate change. And thirdly, the designs based on current flood maps are not protective of future conditions because, again, the mapping reflects prior flooding patterns and doesn't reflect changes due to climate change. So I started out in the beginning saying that I'm going to give you a spoiler and tell you at the end what we're going to do, and then I told the story of how we got here. I think it's important for everyone to understand the thinking process that we've had at DEP as to why we need to do this. And we had announced back in May that we would propose these changes on an emergency basis. And we had a lot of conversations afterwards, and we felt that it was important for a lot of reasons to have conversations, again, like we're having tonight, about how we got here, what we intend to do, why we intend to do it, and to give people an opportunity to comment. So in the near future, we plan to file this rulemaking, which I'll go over some of the key points, with the Office of Administrative Law. And about a month later, they publish it in the New Jersey Register. So the anticipation is that sometime this year, we would see a published proposal in the Register. That starts a 60-day comment period, and everyone can see the rule text, they can read it, they can comment on it, They can provide the department with comments. And then after the comment period's over, the department staff will review every comment. We respond to every comment. Comments are very important to us because it shows us how people are understanding the rulemaking. It shows us, provides opportunities for us to clarify things. In some cases, it points out problems that we didn't foresee on proposal. And so it's a very valuable process. It takes time. So once we develop our comment response, we would file the adoption with the Office of Administrative Law. And then it's subsequently about 3 weeks later or so, it gets published in the New Jersey Register. And the new standards that we're talking about today would become effective upon publication, upon adoption in the Register, not upon proposal like an emergency rule. So we're anticipating sometime in the second quarter of 2023 to have these new standards in place. So the key points: we intend to raise the fluvial, the non-tidal design flood elevation by 2 feet. This is something that we had talked about doing as part of the overall NJ-PACT rulemaking process. And we took that rule and we broke off the pieces of it that relate directly to fluvial flooding. And that's the part that we are going to propose imminently. So it's really a two-phase approach. The first part is to do these surgical changes that deal with precipitation-driven flooding. And then that would be followed by the rest of the rulemaking, which covers everything that we plan to do along the coast, changes to our freshwater wetlands rules, changes to our coastal zone management rules, and additional changes to flood hazard and stormwater management rules. But that's subsequent to this rulemaking. So the first thing is it raises design flood elevations by 2 feet. And if you're calculating either stormwater runoff or you're determining the design flood elevation, you have to use future projected precipitation amounts. It also ensures that any permits or authorizations that the state issues under the flood hazard rules or the coastal rules meet minimum NFIP standards and the relevant sections of the Uniform Construction Code. This is extremely important because what has happened in the past is that there's been a lot of misunderstandings about the interaction between the federal flood standards and the state flood standards. And we want to ensure that anything that we're approving at the state level meets minimum NFIP standards for the community, because every community has a floodplain ordinance. And we want to work together with those communities and with FEMA. And FEMA has been a great partner with us on these. And so it just kind of closes a gap that we see in the flood hazard rules. It also requires stormwater BMPs, best management practices, to be designed to manage runoff for both today's storms and future storms, which is a huge thing. And this is for the engineers out there like me that think about these things. There's different methodologies that you use to calculate runoff, and there's the rational method, there's a modified rational method. Those are terms that for calculations that are used, and they don't reflect our current understanding of hydrology. And so we're removing the ability to use that in our rules. And it's pretty rare that we see it, but we wanted to clarify that in this rulemaking. So why are we doing this? We want to ensure, above and beyond anything else, that new investments are suited to manage today's rainfall, runoff, and flooding, and the likely future conditions of the asset over its lifetime, right? So if you're building a home today, or if you're building a commercial building, or building infrastructure, or putting a bridge in or a road in, they're going to be here in 50 years. They're going to be here in 75 years, maybe longer. And so we want to make sure that the added value that's put into the building up front, or the road or the infrastructure up front, ensures to the best that we can that investment is safe throughout the lifetime of the asset. And this is not really different than anything that we do in life in general, right? We always plan for the worst case. We have life insurance, we have medical insurance, we have plans for what could happen if the low probability things in our life that could happen that have big impacts. And flooding is one of those things. And it's very important to respond to the fact that flooding, that risk, is getting bigger over time. So the second thing, of course, is that having rules in place that have future flood elevations in mind and account for even the changes that have happened already, that supports the wise deployment of IDA recovery funds and water infrastructure investments. And very importantly, it informs new development and reconstruction, people occupying, renting, building, buying properties of where the risk is, but it does not apply to existing development. So one of the questions that we get is, so I have a house and I'm in a floodplain and you're gonna raise the flood elevation by 2 feet with this rulemaking. So do I have to elevate my house? And the answer is no, unless you are substantially damaged, which means you had damage to the house that the cost of which is more than 50% of the value of the building, or you are voluntarily proposing a substantial improvement to the house, you're putting an addition on or a second floor or something like that, then you would indeed have to elevate your home or your business or floodproof it, right? There's different options in the rules. But other than that, it doesn't affect any existing development. And it doesn't affect flood insurance rates because flood insurance rates are set by the flood insurance rate maps. And so none of this rulemaking changes the FEMA maps. FEMA changes the FEMA maps. We're taking the FEMA maps and adding what I'll call a factor of safety on top of it to ensure that people are safe in the future. Now, how does this play out specifically in the flood hazard rules? So I mentioned that we're proposing to raise flood elevations by 2 feet above the current standards. So if you're using methods 1 through 4, which are based on maps, FEMA maps or state maps, then it's 2 feet higher than what's today. So you would use the flood elevation map by DEP plus 2 feet, or the FEMA map plus 3 feet. Whichever one of those is higher, that's what you would use as your regulatory flood elevation or your design flood elevation. There's a means in the flood hazard rules to approximate floodplains if no mapping exists. And there's tables and charts there that you can use, and they're very conservative. And so we're adding 1 foot to those elevations that are in those charts and tables because that accurately captures the increases in flood elevation. And if you're using method 6 to calculate flow rates, you would need to compute the flow rate based on the future anticipated 100-year storm and then add 25% to that flow rate. So you would use not today's precipitation, but the precipitation from the year 2100 that is in those tables that I showed you before that will be in the rules. And you would calculate your runoff and calculate the flood flows and then increase it by 25%, which is what we do now. And that becomes your floodplain. So how does this affect existing development? So you can see these 3 homes here. And let's say that this is today's flood hazard area. This is the lands that is currently inundated by a flood if it happened today based on our flood hazard rules, based on the mapping that we have. So in this case, this might be a 3-unit subdivision, but only the house that's red, only the red house actually is in the floodplain. So that only the red house needs to meet those flood hazard standards. By adding 2 feet, not only does the flood elevation go up, and the land and buildings and structures and infrastructure that's in the floodplain are anticipated to be flooded by more water, it also expands the horizontal extent of the floodplain. So that blue house that you see there, they don't know that they're in a floodplain. They don't know that they're potentially at risk because they're outside the mapped flood zone. And so they probably don't have flood insurance. If we didn't have standards there, they could build a basement, and we've had people trapped in basements during floods. And so it's important that people understand the risk. And the reason why I show that illustration is that it also helps me explain how we apply the rules to development that's already happened, how development that we've already permitted and whatnot. So I'm going to toggle back and forth between these two. So all regulated activities upon adoption of the rules would be subject to these new standards unless one of 3 things happens. The first is that if you're proposing an activity that's part of a project that already has a valid flood hazard area permit. Now that might seem obvious, but what that means is that even though we're changing the flood elevation, if you already have a permit from us, then the activity is covered by that permit and you can do what the permit is authorizing you to do. It doesn't affect that. The second thing is, let's say that the regulated activity that you're doing is part of a project that needs a permit, and a complete application for that permit was submitted to DEP prior to adoption. Now I'm going to go back and toggle this. So let's say today you have a 3-unit subdivision and you only needed a permit today for that red house. But upon adoption of the new rule, you also technically would have needed a permit for that blue house. Well, if you come to us for a permit for your subdivision and includes all those homes, we're going to look at what's currently in the mapped floodplain, and that's what we're going to give you a permit for today. So if you apply for a permit before the rule change, then anything that you're doing as part of your project would be grandfathered from the change. And the third thing is that, let's say that you didn't need a permit at all from us, right? Let's say this yellow house, it's outside today's floodplain, and but let's say you're only proposing that and now it's in the floodplain, or I guess the blue house would be a better example. So let's say that all you were doing was proposing that blue house, and it's not in the floodplain today, but it is upon adoption of the rules. Well, you couldn't have been grandfathered because you didn't need a flood hazard permit before the adoption. So in a case like that, if you've received all necessary federal, state, and local approvals and shovel ready, you can begin construction. And in fact, you do in fact start building, and the rule talks about what commencement of construction looks like. Then as long as you do that before the rulemaking occurs, then you're grandfathered from the standard. But everything else, anything that doesn't meet one of those three categories, has to meet the new standards. Now, we've talked a lot about the flood hazard area rules, but an extremely important component to this is the stormwater management rules, because the two of them are linked. And the flood hazard area rules cover land that's inundated by floodwaters, but the stormwater management rules cover the entire state. It covers any project that is a major development. A major development is any activity that disturbs more than an acre or more of land, or which increases impervious surface or motor vehicle surface by a quarter acre. So any development, you could be on the top of the hill, far from any wetland, far from any flood hazard area, but you could have a major development. And so the new stormwater management rules would apply. Now, all major developments are subject to the new standards on adoption unless, and there's two outs. One is you need a flood hazard or coastal zone management or freshwater wetlands or highlands approval, and you've submitted a complete application to the department before the adoption, then you're grandfathered, because we always look at the rules that are in place at the time that a complete application is received. Or let's say that you're on top of a hill and you don't need a wetlands, flood hazard, coastal permit, or highlands permit. And you've received certain local approvals that are listed in the stormwater management rules at 7:8-1.6, pursuant to the municipal land use law. If you've obtained those, then you're grandfathered from the new changes, as long as that occurred before the adoption. Now, it's important to note that municipalities, of course, through their MS4 permit, they all have stormwater management ordinances, and municipalities have a year to adopt the new requirements. If it's a project that's covered by the residential site improvement standards, though, that has to meet the standards as on adoption, because the residential site improvement standards, which cover residential improvements, right, two or more units, they incorporate the stormwater rules. So upon adoption of the stormwater rules, it immediately applies to something covered by RSIS. But other development that doesn't need a DEP permit, but only needs a municipal permit, if it's not covered under RSIS, the municipality has a year to apply the standard to that by updating the ordinance. And of course, we're going to work with municipalities to do that. So we talked a lot about the impact of raising the flood elevation 2 feet and how to calculate it and the different ways that we use maps. But let's talk for a while about how stormwater management will be affected by this proposed rulemaking. So I'm going to show you a few illustrations, some kind of test runs that we did on some different scenarios to see what the increased amount of precipitation would do to BMPs. And it's difficult to come up with a one-size-fits-all approach to this because there's so many different factors for a given development: the existing land cover, the type of development, the slope, the soil type, your groundwater location. There's so many attributes that you have to take into account when you're designing a stormwater management system. But what we did was we took a couple cases and we said, let's assume that a certain development is happening and we're not going to change any other factor. We're just going to change the runoff amounts from existing to proposed and see what that does volumetrically to the amount of runoff. So what we found, and I'll go through this, is that adjusting to today's rainfall data from the 1999 to today, or the 2019 data, I'll call it, is a nominal increase in the size of the BMPs. And there's a slightly larger, but also, in our opinion, nominal increase in the amount of the BMP that would be added to account for the future year 2100 precipitation. So let me walk through the examples and I'll show what our thinking was. Let's say that you had a 2.5 acre site in Sussex County. So we picked 2.5 acres because that's the size of the drainage area to maximum size of the drainage area to BMP. And let's say today it's forested and undeveloped. And I picked Sussex County because that was where the greatest amount of increase in runoff occurred. So let's say you took that site and completely paved the entire thing, put pavement and buildings on the entire thing. So it went from 0 impervious to 100% impervious. So we calculated what the runoff would be. And again, we had to make some assumptions about how deep the basin could be, what type of basin and whatnot. But in this exercise, we said, okay, based on the 1999 data that we're currently using, depending on whether it's soil type A, which is the most permeable, or soil type B or C or D, which is the least permeable, there's a certain percentage of the site that would need to be dedicated to that BMP. And so you can see the percentages that are listed there that would be dedicated of the site to that BMP to manage stormwater. So if we keep everything the same, but we just change the rate of rainfall to adjust to today, based on the studies that we talked about earlier, that account for the changes in the last 20 years, you can see that it's a nominal increase in the area of the site that would be dedicated to the BMP. 0.4% is the highest in this case. Now, obviously, because the increases in runoff in 2100 are greater volumetrically than they were that have happened in the last 20 years, you need more land to accommodate, in some cases, maybe in a lot of cases, to accommodate that runoff. But what we found is that, again, it's a relatively nominal increase. We found that it was as much as maximum of about 2.5% of the site would have to be additionally dedicated to stormwater management in their BMP. Now, again, this depends on where your groundwater table is. You might be able to go deeper and not have to have that much of an increase in the area of land. You might be able to have different means of storing the water or reusing the water. There might be different things that you can do that would reduce it. But just taking that case scenario, that kind of case scenario, and changing just those factors, this is what we found. So we did another example. Let's say it's a residential, and again, well, it's the same 2.5 acre site. Let's say it's forested today, and it's being turned into a 5-unit subdivision, half acre zoning, 5 houses, 2.5 acres. Again, Sussex County. So based on today's runoff, the 1999 data, there's a relatively small percentage of the site that would have to be dedicated to manage stormwater for a given BMP. And again, as we saw with the other type of development, a minimal nominal increase to be adjusted to today's data. And it's hard to argue against what's happened already, right? We have data that says this is actually what has happened already. And we have very firm data that says this is what is very likely to occur by the end of the century. And so again, with only a 2% increase at the maximum in the land area of the site, you can manage not just today's runoff, but future runoff. So people that live near and downstream of this BMP will be safe not just for today's flows, but for the future flows that are likely to occur. So I know I covered a lot of ground. I'm happy to go back on anything. At this point, Lauren, can we open it up for comments or questions?
Hey Vince, Lauren had to step away, but yes, we just opened it up for questions.
Oh, thanks, Jess. All right. Why don't I stop? Well, I'll leave my screen up just in case we need to go back. Let's see. I need to be able to see those comments though, unless you read them to me. Let's see here. How would I go about seeing? Is it under questions? Oh, there we go. All right. Let's see if I can expand this. All right, bear with me. I apologize. It's hard to figure out how to use some of these. Technology is great when it works, and it's not so great when it doesn't work, or it doesn't work the way they hope it to. Okay. Let me see if I can expand this a little bit more. I can see some of that. There we go. All right. Thank you for bearing with me. Hi, my name is Megan. I'm the Hurricane Ida Recovery Organizer at the New Jersey Organizing Project. I appreciate how much you've spoken about the hurricane Ida tonight. I'm concerned that those who already live in these zones, the very Hurricane Ida survivors you're talking about, who are likely to have substantial damage, will not be able to pay to keep up with the mitigation efforts these rules will impose on them. And so I know you're saying you're not opposed to the changes, but you're concerned about the impact, and that is a very important thing to consider. When someone has flood insurance, there's a certain part of that flood insurance that is called ICC money, and that's increased cost of compliance. And so what we saw during Hurricane Sandy and other hurricane events or other storm events is that because the state of New Jersey and because most of our communities have higher standards than FEMA, that increased cost of compliance money will cover exactly that, the increased cost of compliance. So if we didn't exist and FEMA, the FEMA National Flood Insurance federal minimums were the only standard available, then insurance companies would pay for people to build to that standard, which would be at the existing special flood hazard area elevation, right? The 1% flood elevation. But already in New Jersey, because we have higher flood elevations that we've adopted through our rules over time, that increased cost of compliance money can be used to rebuild the house higher. And so we found that the incremental cost of going additionally higher is minimal, because if you think about the amount that it would take to elevate a home in the first place, going up another 2 feet is in scenarios that we looked at would be a nominal cost. Same thing with flood proofing as well. So I think that covers basically what your question was. Let's see here. So there's also disaster relief money that's available for folks, right? There's a lot of different sources of relief money that's out there. And so it's our belief that the different availabilities of funds for recovery, whether it be through flood insurance or other means, will be able to cover the extra costs of complying with these new rules. All right. Is that the only question that I see?
No, there's more.
I can't seem to see them. I'm sorry.
Did you pop out the question box?
I tried to.
Okay. I was wondering about the method used to calculate future precipitation change factors. What future climate scenarios were considered? RCP 8.5 or lower emission pathway? Did climate teleconnections play a role to obtain change factors? Thanks.
Sure. Thanks for reading that for me, Lauren. I apologize that I can't see the chat easily. So, the data that we used, the scenario was based on a moderate emissions scenario, and it represented the high end of the likely range of the precipitation increase. So as I mentioned earlier, that's the 17% to 83% likelihood range. And so we looked at the highest end, which is the 17% range. So the numbers that were used in that table, there's a 17% probability that the precipitation could increase by more than those amounts. And Lauren, can you read the second half of that question to me? I apologize.
Sure. What future climate scenarios were considered? RCP 8.5 or lower emission pathway? Did climate teleconnections play a role to obtain change factors?
I would love to have a long conversation about the details of the study and the different things that were used, and I could definitely do that offline. I think it goes beyond the scope of what we can do today, but it is a very good question. And the simple answer, as I mentioned, is that we use the moderate emissions level, and we use the high end of the likely range. But shoot me an email. You can see my email address up there, and we can get you some more specific answers.
Okay. Jake Schwartz asks, why is D soils the largest percentage of site for BMP?
That's a great question. So D soils have the least permeability, right? So they have the least infiltration rate. A has the most, and B has less, C has less, and D has the least. And it just played out the way that the runoff interacts with the soils, that you end up having more of, it actually was different than what I thought. I thought that the biggest change would be for A soils, right? Because existing permeable soils, if it's a forested condition, a lot of it's being absorbed, and then you're paving it, and there's a lot more runoff. But the way that it worked out in the calculation, surprisingly, a lot of times D or C was the highest amount.
Is the 2-foot LDFE increase consistent with the model floodplain ordinance?
So the proposed increase that we're discussing today, there are some communities that have, so every community has a floodplain ordinance, right, in order to participate in the National Flood Insurance Program. And FEMA and the state obviously encourage communities to adopt standards that are more protective than the federal minimum. So a lot of communities have adopted higher standards and already say we're going to use the base flood elevation plus 1 or 2 or 3 in some cases, right? So when we change our rules, the floodplain ordinance needs to incorporate the new rules as they're adopted, right? And there's a certain amount of time that they have to do that. And so communities would have to adopt the higher flood elevations that we are proposing here on adoption as their minimum. So they might already exceed that, but in a lot of cases they don't, but that will become the new standard across the state.
Jennifer Coffey from ANJEC says, thank you for the thorough presentation and all the DEP's work on this. When is the department planning on releasing the proposed rules?
Thanks, Jen. Good to hear from you. So we do plan to do it imminently. You know, the thinking is that we have a rulemaking ready to go, and that we would propose it very, very soon, and that it would be published this year is the intention. So even if we filed it today, there's a certain amount of time that the Office of Administrative Law needs to review the material. And so if we filed it right now, it would be published in the December 5th register. I think it is Monday, December 5th. If we file it a little later, it will be in the next register in December. So I can't guarantee you it'll be one or the other, but our intention is to do it imminently.
Doreen Gorelick, will the DEP have discretion to apply these new flood standards to applications it is reviewing currently before the new rules are adopted?
Can you repeat that? I'm sorry.
Will the DEP have the discretion to apply these new flood standards to applications it is reviewing currently before the new rules are adopted?
So no, someone comes in today, let's say we propose these rules and someone comes in today with a project that meets today's rules but doesn't meet the proposed rules. I and our staff will encourage people to meet the new standards to the extent that they can. And there are some parts of a project that will more easily be able to be adapted to the new rules than the others, right? And so I would do everything I could to encourage someone to meet the new standard, but people would not be required to meet the new standard until the adoption of the rule.
Grant Lewis says, hello, Vince. Will a project still be grandfathered in the future if you have to apply for a flood hazard area permit extension?
Hey, Grant, that's a good question too. So if you look at the language in the flood hazard rules about extensions, it talks about that we can extend a permit in certain scenarios. And generally those scenarios are that the site conditions haven't changed, that the flood mapping hasn't changed, that the riparian zone hasn't changed, that the project hasn't changed. So in general, if the floodplain is getting bigger and we now have better data that shows what's happening in the future, that could affect a project and you might not be eligible for an exemption. For an extension. So it would depend. It depends on a lot of factors, because you could have a situation where the proposed change in the floodplain doesn't actually impact the project because of the type of development. Let's say you were doing, a recreational field and there's no requirement that the field needs to be elevated above the flood elevation, right? So bumping up the flood elevation 2 feet doesn't affect whether or not we would have given you a permit for that. So that would be fine. That would be something that we could extend. If it's something like a building that has a floor elevation that now doesn't meet our standards, we probably couldn't extend that. So you might need a new permit in those cases.
Stacy Fox says, this sounds like an emergency given the costs of human life and tax burdens to cover the uninsured. Why would any project be grandfathered in? Stacy Fox, Mercer County Defense League.
Thanks, Stacy. I appreciate that. And you know, you share our concern for the public, and you know, we have worked diligently on this, and we wanted to make sure that we got it right. We wanted to make sure that we understood the science, that we understood the interactions of the mapping and whatnot. And so now that we're at this cusp of proposing it, we will do everything we can to adopt it in a as quick as possible manner, because we do agree with you that we want to put these standards in place as soon as we can.
Teresa Callahan asks, does a 20-house subdivision have to meet RSIS standards and be subject to these rules?
So a residential subdivision would have to meet, no matter what size really, would have to meet the residential site improvement standards. And those standards cover a lot of things, right? Like the type of roads and all sorts of things about the development. And one of the things that the residential site improvement standards require is compliance with the stormwater management rules. So that would automatically kick in if we change the stormwater management rules.
Brian Tarantino says, thanks again for the presentation. Can you explain again the application of the rules to new development? On one slide, you said that unless construction started, the new rules would apply. On the following slides, you indicated something else.
Sure, let's see if I can go back a slide. All right, I'll do it this way. All right, let's see here. So I should point out too that because we're recording this, the recording will be available to everyone. And also the PowerPoint that we're showing will be available to everyone. So you can go back and look at this data. So I think you're talking about something like this, right? So here's I think that you're speaking to this. Here's a situation where you have these 3 homes that are being proposed. Today, only the red house is in the floodplain. Only the red house needs a permit from us. But let's say that your plan was a 3-unit subdivision, and you were going to build all 3 of these houses. So you're getting a permit for the site, and the site, as the permit for the site includes basically everything on the site because of stormwater runoff and whatnot, right? Because we look at stormwater management from the whole site, not just the part that's in the floodplain. So even though technically in this case only the red house is in the floodplain, the yellow house and the blue house, if they're part of the same project, that's covered by that permit. And so the rule changing to now pull in that blue house doesn't affect the blue house as long as that permit's valid. Now, once the permit expires, then that blue house, if it hasn't been built yet, it would definitely need a permit as well as the other ones. So I think that gets to what you're asking.
Julian Waldman says, any idea how the new rules might interplay with municipalities, for example, Lambertville, that grant historical waivers for properties sitting in FEMA certified flood zones that were, for example, substantially damaged? Will the new rules address this? In Lambertville, it seems to be operating as a backdoor to avoid what I consider to be vital community safety measures. Thanks.
So it's true that communities can issue variances or waivers from their standards, and there's a process that they have to go through as part of their floodplain ordinance if they're proposing something that doesn't meet federal minimum standards as adopted in the ordinance. However, they also need a flood hazard area permit. So it wasn't that long ago that there was a building in Lambertville, and someone wanted to put an addition on the building, and it was not entirely clear whether the addition constituted a substantial improvement or not. But regardless, any new construction under the flood hazard rules has to meet current standards. So the new addition needed to be elevated or built higher than the rest of the house, and it was about 5 feet higher than the rest of the house. And the owners didn't want to do that, and we felt that it was incumbent on us to make sure that they did do that. And so we required that this addition be 5 feet higher than the rest of the home, and they were very badly impacted during Ida. I don't know if because I actually went to that neighborhood afterwards. I don't live far from Lambertville, and I saw what happened, and they were very badly impacted. And so I was glad, I don't know if they completed their addition or not, I couldn't see, but I'm very glad that we we made sure that they use those higher standards. So it's very rare for the department to issue hardship exceptions on floor elevations, especially for residential buildings, because the fact that floods can happen in the middle of the night, you can get trapped, you can die in your home if you're not at the right elevation. So it's a very rare and generally focused on like impossibility of doing the activity. But if it's a new addition, or if you have a substantial improvement to the building, then we're going to say it needs to be elevated. And that's completely independent from what the town might require. The town might be able to give a variance, but it would be unlikely that we would.
Gang Yin says, we usually use the rational method to size the storm system. After the new rule is adopted, can we still use the rational method, or do we have to switch to the NRCS method to size the pipe?
So you would need to use the NRCS method. The rational method is not something that the rules would allow you to use.
Alan Melia, if a town does not maintain their waterways, the flooding will continue to increase even with new maps or regulations. How does one hold their town responsible for maintenance?
So I think maintenance, you mean like keeping the waterways clean from debris or sediment. So it's a really interesting thing. There are certainly things that can happen in a channel, in a water course, that block flow, right? You know, we saw that during Ida in Lambertville. There was a home along Swan Creek that ended up in the channel, and it blocked the bridge completely. And so if there was another flood, the whole neighborhood would have been devastated. So there are times where large pieces of debris, trees, things like that clog up bridges, culverts, or somehow, you know, impede the flow. And it makes sense that a community would go in and try to take those things out. Oh, you know what? I want to pause for 1 second on that. I think I misunderstood the question about the rational method. When you're talking about pipe design, you can still use the rational method for the pipe design, but for the runoff from the site itself, you would need to calculate using the NRCS method. I misspoke before, so sorry about that. Going back to the prior question. So yes, you can use the rational method to size the pipe, because that's something completely different. All right, my apologies. Back to this. What we've seen though is that sometimes you do have situations where sediment and debris have accumulated in an area and has caused a major obstruction to the channel. But if you look at a typical channel, a stream channel, and then the size of the floodplain that is associated with that channel, a lot of times the amount that's being conveyed by that channel is just a small part of the entire floodplain. So the channel, on average, you can estimate carries about, say, the 2-year storm, right? So by removing the sediment and debris from that channel, unless it's like a significant blockage, it doesn't seem to make much difference in flooding events, because there's so much water that it's not conveying that much extra water by just removing the sediment debris. So it really depends on the scenario. Now, it's interesting because a lot of times streams are owned by private property owners. They're not owned by municipalities. Sometimes municipalities or counties have easements and there's certain agreements and whatnot. But if I have a stream on my property and there's an obstruction in it on my property that's causing someone else a problem, it's on my property. So technically it's likely to be my responsibility. So it's a very complicated thing. We have some data, we have some information that is on our website that talks about stream cleaning and the do's and don'ts of it and how you can go about doing it and the types of things that need permits and don't need permits. So if you have any more specific questions about it, you can email me.
Jake Schwartz asks, when designing a site, is the pre with the 1999 storms and the post with 2100? Or do you look at pre and post for each projected storm?
So that's a great question, because we looked at, do we make people design us? So today you have to show that you calculate the runoff for the existing conditions and the proposed conditions for the 2-year, the 10-year, and the 100-year storm, right? So there's 3 sets of calculations, 6 really if you existing or proposed. So we wanted to ensure that for all of those storms, the 2-year, the 10-year, and the 100-year, that they not only meet and manage runoff from today, but also for the future. So if we only required you to meet the 2, 10, and 100 for today and then the future 100-year, we'd be missing some storms in between. So the rule proposal, as you'll see, will say you need to show that you demonstrate compliance with today's 2, 10, and 100 years runoff, and also the future 2, 10, and 100-year runoff based on those adjustment factors.
Teresa Callahan, isn't there a risk that developers will evade these rules by commencing construction, by doing some minimal disturbance?
Well, if they're in the floodplain today, in today's floodplain, they'll need a permit from us before they can do anything. If they're outside the floodplain today and they didn't need a permit from us at all, they could go to the town and get their construction permit, and they could start work in the area that's outside today's floodplain, but not in the future, but outside today's floodplain, but inside the future floodplain. So like on this, you see on the screen, that blue house is a good example, right? So let's say that blue house was a standalone development and you didn't need a permit from it today, and you went to the town, you got all the construction permits that you needed, any other kind of approvals that you needed, and you were able to be commencing construction, then you can do that, and then you would not apply these standards. Most cases though, if you're in the floodplain, if you have a project, there's probably some component that's in the floodplain and you already need a flood hazard permit for something on the site. And so, you know, one way or another, it's gonna probably be caught.
How are the new rules going to impact public projects?
So public projects, the starting point in all of our regulations is to say, because of the risk that's commensurate with different activities, whether it's private development, public development, infrastructure, all has to meet the same standards as a starting point. Now, that being said, depending on the type of development or the availability of resources, the ability to retrofit things, sometimes public development can't be made to fully comply. So the rules, we have a hardship exception process. We've got in the flood hazard rules, we have standards in the stormwater rules that provide flexibility for certain transportation projects. So the starting point is always going to be, we all need to meet the same standard because we're all using the same roads and buildings and infrastructure. But there are some elements that are specific to public projects that might not be the case in private projects, where additional flexibility might be warranted. So the rule would spell out in detail what that looks like and when that would apply and how we would apply it. But in the end, there has to be an assessment of what that impact is going to be and a demonstration that people aren't going to be adversely impacted.
Aside from the new standards, you need to get claims flood incident disclosure as a requirement going forward. More of a comment.
So disclosure is something that we also agree, if I understand your comment. You know, people buy homes, they don't always know that they're in a flood zone. If their lender tells them, then they know, but it could be an area that's not mapped, right? So we already have some disclosure language in the flood hazard rules where if you're building something new and it's in an area that we know it's a floodplain, you have to put a note on the deed that explains that this property is subject to flooding, and you have to verify the limits of it, and that has to be all incorporated into the deed so that people know 10 years from now, 50 years from now, that yeah, there was a record of flooding here. As I mentioned earlier, we have the overall NJPAC proposal, and we've taken out these pieces that are related to precipitation-driven flooding and putting it out first so that we can get them adopted as quickly as we can. The rest of the rulemaking covers a gamut of things that are related to flood risk that are even beyond the scope of this current rulemaking. And one of those things is disclosure. One of the things that we've talked about is having people assess their impact assess the impact of climate change on the project, assess the impact of flooding on the project. What's their plan if something floods? And so that's all going to be built into disclosure language that would be incorporated into the deed. So look, going forward, we will have our proposal will have much better, more detailed language associated with that.
Steve Florman says, adding 3 feet to the current FEMA 100 year gets us a cafe to design to. But how does DEP anticipate a project such as a bridge replacement that would use FEMA hydrology today in a hydraulic model to determine impacts to the floodplain? Method 6 to calculate hydrology would be overly burdensome for a project along a large river like the Raritan or Passaic.
Hey, Steve, that's a good question. And I think you're talking about the difference between, say, method 4 and method 6, right? So method 4 was developed just for that, because back in the 07 rules, we recognized that if someone were, say, replacing a bridge and you need to do routing of that bridge to show that you're not having offsite impacts, what was most relevant was that you just look at a range of storms and show that for the range of flood events that it's not going to cause an offsite impact, right? So the rulemaking doesn't change. So if you're analyzing a bridge, you look at the 2, the 10, the 25, 50, 100, and then the design flood. So it doesn't change. So if you're using method 4, 2, 10, 25, 50, 100 don't change. The only thing that changes is that design flood elevation. And in the larger proposal, we are indeed calling it the climate adjusted flood elevation, the CAFE. In this proposal that we'll be coming out with soon, we're not changing the terminology because it's more of a surgical change to how to calculate the floodplain, how to calculate stormwater and whatnot. So we're using the same design flood elevation term, but the design flood elevation would be 2 feet higher. So what you'd have to do is you'd have to, in your hydraulic model, or your hydraulic model of the bridge, you'd have to increase the flow rate so that you get to a flood elevation that is 2 feet or 3 feet above FEMA's 100 year, and then wrap that. Now, in a lot of cases, it's just going to overtop the road anyway, and so your offsite impacts are probably nominal. Your offsite impacts are probably more noticeable for the smaller storms anyway. So I don't think that's going to be a problem in most cases, but you would have to, I guess, iteratively determine what the flood elevation, what flow rate would result in the flood elevation of that high. And so you wouldn't have to do a whole analysis of the river, but you would have to at least have enough cross-section data and geometry to be able to calculate that out at that location. Hopefully that answered your question. We can chat more about what that looks like offline if you'd like.
Jennifer Lastella says, thank you for the informative presentation. I apologize if you covered this and I missed it. Can you clarify when an applicant can be grandfathered under the existing rules? An application under review is considered complete. Do you mean technically or administratively complete? And for those that were submitted but not yet complete, will those applicants then receive a deficiency or request from the department to redesign in accordance with the new rules?
That is an excellent question. So when we say complete for review, we mean an application that's both administratively complete and technically complete. So administratively complete means you paid the fee, you signed all the right forms, you provided all the material, and technically complete means that it's ready to be reviewed. So you submitted the right calculations. We might decide upon review that the calculations need to be adjusted, or we might, adjust the design of the project with the design professional. But if all the pieces are there and all the relevant data has been submitted, it's administratively complete and technically complete. Now let's say that the day before the rule is adopted, somebody submits an application. And of course, it's not going to be reviewed, within 24 hours. So we won't know if it's technically complete and administratively complete until a little bit after the rulemaking occurs. So let's say that the rule is adopted on a Monday and the previous Friday, somebody submits an application. So at some point in the future, after Monday, staff would look at that application and determine whether it was both administratively and technically complete. If it's both, then it's complete for review and it's grandfathered from the new rules. If it's not both, if it's administratively complete but not technically complete or vice versa, then it's not complete for review before the rulemaking. And so therefore the person would receive a deficiency letter and say, you submitted this application before the rule change. However, the rules have changed. You did not submit a complete application. You have to address the deficiencies, and you also have to make sure that the project meets the current rules that are in place.
Chris Kane asks, how will the approximation method be incorporated?
So method 5 in the flood hazard rules, the approximation method, is a variety. It's as you know, I'm sure there's different tables, right? There's you look at the depth, the average depth of the flood at a stream at a given location, and it tells you where you're, depending on what watershed management area you're in, what the flood depth is based on the drainage area. And it gives you a value. And then also it gives you a value for, if you have a culvert that's, the assumption is that a culvert or bridge downstream from you might overtop. And so there are calculations to show how deep the overtopping would be based on the drainage area. So what we've done in the proposal is we bumped up the numbers by 1 foot. The reason why we bumped them up by 1 foot across the board instead of 2 feet is that the approximation method was, we developed that for the 2007 rules, and we've used it a lot. And we felt that it was conservative enough. The plan, when we adopted it, was we wanted to make sure that it was going to be conservative enough that we didn't miss any floodplains. And so we feel that adding 1 foot to it, and you'll see the description of this and the explanation of this in the proposal, we feel that adding 1 foot to the approximate method adequately covers what will happen with climate change. But if you're basing it on maps or on calculations, then it ends up being 2 feet.
Mayor Richard Underco says, Vince, will you visit ground zero for the adverse effects of poor stormwater management? And why is DEP ignoring the need to mitigate lower floodwater levels? What actions can be taken?
Mayor, I'd be happy to come take a look at what you're speaking of. I'm always happy to do that. Lauren, can you read the second part of that again, please?
Why is the DEP ignoring the need to mitigate lower floodwater levels? What actions can be taken?
To mitigate lower floodwater. Mayor,
lower is in parentheses, so mitigate parentheses lower and
right.
Parentheses floodwater levels.
Mayor, if we could, let's talk offline, because I'm not entirely sure what you're asking, and I don't want to give you an incomplete answer. So why don't you reach out to me, and then Jess, are you still on the call?
Yes, she's here.
Okay, Jess, if Mayor, if you could reach out to me and Jess will make sure that we'll put some time on the calendar to talk.
Elena Haydo says, are there any legal implications to municipalities who delay development proposals until this plan is in effect?
Well, if they delayed, you mean like if someone purposely delayed it on the local level so that it had to meet the new rules? I think that's what you're getting at. I mean, I don't think that the state would have the ability. The rules are designed to say, if you're building in this area, this is what it looks like. I think that would have to be something that would be addressed between the developer and the municipality as to whether or not they acted appropriately or not. I think we're almost at 8 o'clock. Maybe do one more question, Lauren.
That's what I was just going to say. Yep. All right. In a proposed development that gets approval prior to the rule being implemented, is the whole development grandfathered regardless of any units that may end up being in a flood area?
So if a project, let's say that there's a 20 unit subdivision and 5 units are in the floodplain today, and the person applies for a flood hazard permit, and we look at stormwater runoff for the whole site, because that's what we do. It's not just a part of the floodplain. And we give the person a permit based on that, then the expansion of the floodplain doesn't interfere with the development of that property. So even though today, based on today's mapping, maybe 5 houses are in, but 7 or 8 houses are going to be in afterward, because the project was part of something that needed a permit and got a permit, we're not going to take a second bite at the apple and go back and take that new area. I think that answers your question. you know, I'm much more used to dialogue. I'm much more used to having an interaction with folks, and so hopefully I've addressed mostly what you've asked, and I know that we probably have a lot more questions that are awaiting my attention. So just like we did in the webinar yesterday, we have a table that shows all of the comments, and so we will read all of them and consider all of them, because it is important. We want this to be understandable to folks. We want it to be clear. We want people to understand our intention, to know when the rule applies and when it doesn't. And I just can't thank everyone enough for spending 90 minutes of your Thursday night talking about this issue. It's obviously important, and I'm glad that you all feel the same way. And we're all in this together, and we're going to make this work. And I look forward to your review of the rules and your comments on the rules. So thank you very much.
Thank you, everyone. Have a great night.